Good morning, everyone. My name is Christian, and today I thought let's try something different. I was reading Matthew's blog the other day, as you do, repeatedly, and I figured, hey, well, I processed another of his posts in my Zettelkasten recently, and he liked the result and the insight of how to process stuff like this into a Zettelkasten, like looking into the process. So I figured maybe you do too. So here's a live recording, a read together, let's say, of me doing that. I just opened a random Swift Evolution post. I realize it's over a year old by now. I figured these were all from this year, but they aren't. So I'm really behind. So this one I haven't read. It's Usability of Global Actor Isolated Types. Swift Evolution Proposal 0434. Global actors are central in the vast majority of Swift programs. Yes, main actor. So I've never used global actors myself, I believe. No, I believe I haven't. I've used actor types sparingly, but on the odd occasion. They actually worked fine to protect resources. So defining a global actor, I recall that people really wanted to have this when Swift concurrency was new, because main actor isolation was, well, very limited, and they could use the global actor, but they couldn't define multiple global actors. Is this it? Let's see. So here's my note-taking app. I put everything in full screen in a virtual desktop here without the menu bar, so you don't see the recording icon at the top. Let's just start with something fresh. So I create a new note. Why do I create a new note? Because I want to process this thing. It's probably Swift Evolution Proposal 0434. I began tagging my notes with these because I will forget the number, but when it comes to concurrency, people throw them around sometimes, so it is a useful trail to search for, I believe. Maybe it doesn't pan out that way, but so far I haven't regretted using these. So I read a couple of these posts. They're highlighted in the visited color, but not all of them. So there's a couple of posts we can read together in the future. So have a quick glance. The problem, nice. So this has a structure. This is structure. This post is structure. The problem, implicitly non-isolated properties, just skimming closures, subclassing. Okay, is this a problem or is this a application of the thing? Let's see. The solution, some code, implications. Okay, solution was short. Will it affect me? Wrap up. It's a short one. The structure doesn't immediately make sense to me. Not a critique, just an observation. I want to share with you how I process texts, and this is obviously not an academic text. It's a blog post, so we just put stuff out in one way or another to share knowledge, but this is not, there's no peer review, no feedback, no, hey, I can't read the post based on the structure, and the post is, a couple of hundred words, so who cares? Anyway, no critique of Matt doing this. The implications are short, and implications sound interesting, so I start with this in the middle, and then the end to see, I want to spoil the end for me, and then try to see what the problem description is. In all three of the situations, you may have workarounds in place are just no longer necessary. I don't think I fit the other two issues myself. But there's a lot of references, and maybe I should have started at the beginning. The closure change here is a big deal. Okay, closure, big deal. Encounter this number of situations. And a little weird enough exception. Global actor means sendable rule. Global actor isolated types. So this is not defining global actor isolated types usability, but the global actor, the one that we were used. Let's see. It feels A corner case to me, the situation doesn't come up a lot, but could probably help with migrating pre-Swift 6 code ? I'm not sure. Global actor means sendable rule. Will it affect me? I classify this as mostly a bug fix. The proposal, cool to see other compiler getting smarter about value types. I also don't use subclasses myself, and I have kind of mixed feelings about the new exception. Okay, new exception. I mean, this is stuff I have in my head. Like, I'm framing what I want to read for, what I will hunt and extract, and this sounds like Matt finds this useful. There's a new exception, whatever that means. And also the rule, where was it? What? Mixed feelings about new exceptions, smarter about value types. Was it above here? Exception to global. New exception. Global actor sendable rule. So it's not about a throwable exception, it's about the exception to the rule. The new exception, that must be useful to someone. Okay. The global actor equals sendable rule means sendability. I didn't know about that, so this is new to me. That's definitely going to be a thing that I will end up having in my Zettelkasten in the end. Sendability not required. That makes sense. Then you are not forced to do stuff in a way that's sendable. Wrap up. My original goal was to finish all of these before WWDC. Okay. There's another proposal, distributed actors. Okay. Going through these proposals was incredibly educational for me. I learned a lot more, but probably if I would having otherwise. Nice. Central theme really stood out. Yes, the language has made enormous strides in improving database safety. Yes, lots of new syntax has been introduced, but things have just gotten transparently better. Okay, cool. Majority of all this developer will never need to understand. If you're going deep with concurrency, there's so many more tools. Agree. If you go deep and if stuff works out, this is really great to understand a couple of things and then a couple of things more than the run-of-the-mill developer will ever have to face. But the Swift 6 language mode, Swift 6 language mode, if you adopt it and if you can figure out how to write things in it, then it's really cool. If you aren't, Swift 6 makes it easier to sidestep the whole thing. I still don't feel like I have a good read on Swift 6 language mode. Okay, I also don't have a clue. I heard stories of people enabling Swift 6 language mode, seeing all the errors, and then slipping on. Well, I'm going back to Swift 5. Looks good to me, and that's it. For now, I cannot wait for Swift 6 to be out of beta. Oh yes, that's that kind of time. We're in Swift 6.2, and this was pre-Swift 6. Okay, so for context, there have been even more cool changes ever since Swift 6 language mode has been released that I know Matt likes. So let's see what the post is about then. So there are three pretty distinct things being covered: non-isolated properties, closures, and subclassing. Three things. Non-isolated properties. Compiler gets pretty clear with properties of globally isolated types. If they are sendable, the compiler treats them as non-isolated with its defining module. It knows that because they are sendable. Okay. Enforcing the isolation serves no safety purpose. That's pretty smart. Has to lose restriction. Currently only works for let values. Parenthood. Quick aside, there was a cut right now because I was assaulted by my daughter, who just woke up and then wanted to greet me for the morning. Very cute, but these are like these are interruptions that are very similar to like the annoying colleague at the office maybe, and now I've lost the context and need to recapture it. writing is really good for this. Like if you can capture stuff in writing, then you have something to refill the context. The context here that I captured is, well, there's a new exception to the rule. Global actor is sendable, but the rest, I need to read this again. Which I guess makes this video more honest and practical for day-to-day use. Okay, so 3 pretty distinct things. We have 3 things. Again, implicitly non-isolated properties. Global actors are central to the vast majority. You only need 2 kinds, main actor and non-main actor, but global actors have some quirks that makes for strange, frustrating behavior. The proposal is kind of a grab bag. I still believe that I'm missing context. Again, there are 3 distinct things being covered here. The compiler gets pretty clever with the properties of globally isolated types. They're sendable. The compiler treats them as non-isolated because you can send them, you don't need to isolate them, within its defining module. It knows that because they are sendable, they are actually safe to use from any domain. Enforcing the isolation serves no safety purpose. Is that something? I mean, it's kind of trivial, but I believe I copied the URL of the post, and I believe I haven't captured that information. What did I say was the date? Let's start with the metadata. Published in 2024, July 11th. Wrong shortcut. GAUs. Global actor usability. This is in inline citation. This is the reference manager syntax that multi-markdown introduces. You can use whatever footnotes or just pandoc citation stuff. I'm not creating a new entry in my reference manager for this. I'm just doing this inline. Why inline? Because I'll probably produce a couple of notes here, and I don't need this in my reference manager unless I'm publishing something, and I will probably not publish something as a book that references blog posts. So that's why I start with websites, web links. I put them here, but I don't also put them in my reference manager. This is just too much work for me, too much overhead. Okay, so now we have this, and now we can cite Matthew properly. If they are sendable, the compiler treats them as non-isolated within its defining module. Oops, I'm not sure I knew that. Sendable protocol conformance tells the compiler that the conforming type is safe to use from any domain without additional isolation. The compiler treats sendable. Well, let's stick to the proper format. Sendable types as non-isolated within its defining module. And this is a partial direct quote. So I'm quoting properly. The compiler treats sendable types as non-isolated within its sendable types plural. Okay, a sendable type is non-isolated within its defining module. Okay, now the quote works. It knows that because they are sendable, they are actually safe to use from any domain. Enforcing the isolation serves no safety purpose. its defining module. Isolation domain, we should say. Like, it's not a domain. That doesn't mean module. That doesn't mean app and another app importing the same. No. Isolation domain is probably the kind of domain that we're talking about here. The compiler treats the sendable types as non-isolated within its defining module. But what about others? Like, what are the implications of the isolation implications for modules importing sendable types? I don't know. Genuine question. Like, the compiler treats sendable type as non-isolated within its defining module. That's a proposition. That's a sentence saying something. But what are the edge cases? What are the inversions? What is not being said? Things like this, for now, we have to ask ourselves. So, if it's non-isolated within its defining module, which is very specific, what about other modules? The modules that have not been defining these. And these must be modules that import the module where it is defined, because other modules can call this. Dependency graph works just in one direction, right? So you can only another module that imports its module, the defining module, can pose any challenge here. Other modules that are not related or being imported from the defining module, irrelevant. Does that suffice? Should I sketch what I mean? Like, if we have the sendable type, this module, and that imports module foo, then since it imports module foo, there's no problem. Foo cannot know about this one. But if bar imports the sendable types module, then here we have a dependency that can make, where the compiler needs to do something, make some decision about the isolation domain of whatever this module does by virtue of bar importing the sendable types module. But this case irrelevant, because foo cannot see the sendable type. Next time I'll do a quick drawing instead of typing. That was too slow. Okay. Enforcing the isolation serves no safety purpose. This is pretty smart, helps to loosen, saves no safety purpose. Okay. Thing is, it currently only works for let in value types. Okay, interesting. Main actor, some actor type. Main actor types are sendable by default. Main actor, no, are they? Oh no, this is not finished. When you access self and the have to be sendable. Ah, this is from Matt's video. Non-isolated async functions. No. You made the protocol sendable, now needs actors because it makes usage simpler. Sendability expressed and removable between isolation contexts. Should be probably isolation domains. I don't know what the rest of the note is about, but isolation context, I'm not reading this very often. It could be that I made this up myself. Non-sendable type state. So, non-sendable class runs async functions. You can't easily use them for main actor. Can inherent actor isolation with Swift 6. Also, messy my class. Non-isolated. Non-isolated. These are isolated. I don't know from the top of my head whether main actor annotated types are sendable. Okay, globally isolated types become sendable. Maybe Matt says it right here. Once you apply isolation, the compiler has enough information to keep things safe. Swift evolution 03 global actors. A non-protocol type that is annotated with a global actor confirm. You know, it's right here. I should have just continued reading. And I also should capitalize the hashtag. Swift evolution 03. Dang it. Blind code? No, we don't do blind codes. A non-protocol type. Okay. Instances are safe to share concurrency domains because access to the state is guarded by the global actor. Can only be annotated if it has no superclass. The superclass annotated or the superclass and a subject. Interesting. Didn't know that either. I couldn't have told you that. But I probably would have gotten the usual feedback by the Swift compiler, which is it doesn't work. Yes, I was just reusing the opening brackets here. What? Am I typing the wrong key here? Yes. What's the evolution proposal called? Just global actors? Okay. Swift evolution 0316 global actors. I want to extract this. Global actor isolated types are automatically ascendable. Bam. Extraction complete. C0316. Forgot to include the hashtag, it seems. And for the citation key, I will not use the auto-generated date-stamped ones. I will just use SE0316 or some variation of that. Yeah, now this is now the same as the hashtag, which is nice, in my book at least. If you can annotate a type with a global actor like main actor, the type automatically and implicitly becomes sendable. Becomes sendable, that's a proper English sentence to talk to people. It is sendable, but I mean, I should say it conforms to the sendable protocol, but the quote says it, so I'm fine with this. With the extraction that I've just done, we automatically left a link here. We don't need, whoops. We don't need that tag. Why does it scroll when I, wrong key. Wrong key again. Okay, global actor isolated types of sender. I wanted to forward delete with K, but I pressed the page down button by accident. Global actors, let's go back. Non-protocol type, global actor implicitly conforms to sendable. That's good to know. This isn't actually true for closures, okay? Exception to that rule, which is interesting. It's interesting and also weird. So if I have a closure that is main actor isolated, it's not automatically sendable. But why not? What do closures do differently? They capture context. The context that is captured is main actor isolated as well, maybe? Or is it not? But if it's main, yeah, I mean, if you make the closure sendable, you can only capture sendable stuff, which is stuff that is main actor isolated. No, I don't know. Isolated closures are not sendable by default. The code example is a good illustration as well. I like to, sorry, error capturing non-sendable closure. Right? This is a bit more compact and reflects how Xcode highlights errors as well. So what I want to do here now is, this is a new information. This is new information for which I also need to quote met. Actor isolated closures are not sendable by default. Let's tag it Swift 0316 as well in list and things. Global actors were introduced with the capability to make to make annotated types conform to the sendable protocol by default. This does not apply to closures, only classes. I feel like this is a phrasing that I should use elsewhere. Does not apply to closures, because this is about closures. Where is it about classes? Global actor. Here. Let's go there. You can enter the type. This does not apply to closures, only classes. That's a limitation. So it goes here. actor isolated closures are not sendable by default. I don't need the title again. This is enough for the link context to work. Let's start with the list of limitations. Maybe there will be more. This is a bit more formal and also structured. It doesn't read as well, but it's fine to get a glimpse on. But it's good enough. Like these short lists and these technical phrasings are great to get an overview later, I found. Global actor isolation. This is a variation. This is the backup. I want to cite quote or whatever myself here. So this sentence is backed by that link. Main actor isolated closures are not sendable by default. For example, main actor not sendable by default. That example is by is from Matt. This is good enough for me. Need to annotate the closure as main actor sendable. I still don't know what kind of limitation this is, because if you want to main actor isolate something, then why and how would you want to capture local state in the closure? Why do you want to close over things that are not sendable? If you want to capture references to objects that are main actor isolated, they are by default also sendable. So the sendability annotation will not limit you here when you capture other main actor isolated objects, because main actor isolated objects are already sendable. So I'm not sure I agree with the emoji here. Does it really severely impact the usability? Capturing non-sendable closure in the task, because the task is what does this express? I don't know. I don't know what I would like to express with this if I wrote this code myself. I leave a comment here. I don't know what someone would like to express. This doesn't need to be a comment. I'm confident in this being part of the proper node. I don't know what someone would like to express with the main, with a closure that captures non-sendable objects, values, state. And enforce main actor isolation. I could ask Matt. I should ask Matt. I will ask Matt afterwards. Then we'll see. The only workaround is make them sendable. Okay. Subclassing. A restriction was added to Swift 5.10 to catch a potentially unsafe pattern around subclassing. Non-sendable class. Main actor isolate class. Several different actor isolation. Yeah, this was stated in the. I haven't read the Swift global actor proposal thingy. Sorry, on 6. I haven't read it. You just saw how much I saw. It was a page of text and this one quote that Matt linked to. So let me take this global actor isolation. And sendable. Yeah, I'm not sure. Like the Swift evolution proposal here clearly said a non-protocol type. A class can only be annotated with a global actor if it has no superclass, or the superclass also annotated this way. It was just said right there. You cannot change global actor isolation. Sorry, the sidebar here is getting in the way. So let's increase the surface of the quote. Block quote thingy is too clever. Type hierarchy. Inheritance hierarchy. I mean, it's implied, but just to be sure, inheritance hierarchy. Like this, more like a breadcrumb for myself to think about the proper kind of hierarchy. It types inheritance hierarchies, superclass hierarchy, something like that needs to. It's required to be on the same, to be isolated to the same global actor. No changes permitted. No changes in actor isolation permitted. Yeah, fine with that. So it clearly says it there. But it turns out the problem isn't the isolation. It has exactly the opposite issue of closures. This implicit sendable that comes along with the global actor that allows the unsafe behavior. Okay, what is the unsafe behavior? Do I need to read the? Like I feel like I'm missing context. Usability of global actor isolated types. That's quite long. Okay. Okay, it's not Matthew's fault. The Swift evolution proposal references the limitation. Sorry for implying otherwise, Matt. We propose that stored properties can be declared as non-isolated without using unsaved. So this is, yeah, it's a grab bag, like Matt says. Usability is just like, hey, let's change a couple of ways that things can be used in global actor isolated types. I guess I really need to read this one as well. So the problem description, I'm not, I mean, these are 3 problem descriptions. Solution is straightforward. The compiler is going to get even smarter, but enforces isolation and sendable properties. This is allowed, this is also okay. Non-isolated, but this is sendable. Globally isolated closures are now sendable. Captures a bunch of non-sendable stuff. A fix for the subclassing is a little strange. Globally isolated subclass will now be allowed, but it will no longer get an implicit sendable conformance. Swift evolution proposals. So This is very typical. Global actor isolated types are sendable. This is very typical. 0434. This does not apply to closures. No. I need to reference the other one. Is no. GitHub messes with the copy URL thingy. The copy URL shortcut, and instead copies the full text by default, which I hate. But what can you do? Swift evolution 0434, usability of, and so on. SE 0434. Capital, yeah, I mean, I don't care. If this one is also capitalized. But I want to have this in a consistent way. Even though this is not case sensitive. Usually my side keys are all lowercase with or camel case. Not even camel case, just lowercase. Limitations. This does not apply to closures, only classes. B for Swift 6. Oh no, 3, 4. Want to hashtag this Swift 6.0. Did not apply to closures. So evolution, like imagine I would have captured this information years ago and then never found out about this evolution proposal, and then like reality changes, the rules change. It's really annoying to keep up with this. Like getting into Swift 6 language mode and all the concurrency stuff in 2025 is much nicer than being an early adopter and then having to keep up with all the changes. It's my point of view, at least. I'm really happy that I skipped this for so long. It felt undercooked, and maybe it still is, but it definitely wasn't cooked properly. Types inheritance hierarchies required to be isolated to the same global actor. No changes permitted. You can introduce. No changes permitted. But you can introduce an actor isolation in a subclass. Introduce actor isolation in a subclass. I want to say you can still only do it once, but if you do it later, it plays under different rules. i.e. parent is not isolated. Then, but you can introduce actor isolation as subclass, then it's not automatically sendable. So, and this is supposedly set here. Authors, Matthew Messicotti. Who would have thunk? Okay, it doesn't make sense. No, stop searching. conformance. Okay, explicitly specifying sendable conformance is an error. That is a restriction I would have to think through, but I didn't expect this. Non-sendable test, override test, main actor isolation, okay, matching the isolation necessary to by class, static isolation. This must be so tough to get right. I don't know how they test this. I hope they do. Okay, back to Matt's post. Oh yes, the closure. We need to update these as well. This is only before Swift 6. But I guess now I also don't want to emphasize this so much. Makes it more, I don't know. I want to make this a sidebar. So actor isolated closures are not sendable by default. They now are sendable by default. Are sendable since Swift 6. This is the kind of work I would have done if I had covered all this stuff in my notes back then and then updated them later. So you see this in a very weird way. Like I just created this note and now I already need to refine it because the problem statement, which was true and it read like a truth, has now been revised. I guess large language models will have a really fun time staying up to date with Swift concurrency. Like you probably can't use them at all. I haven't tried. But they surely must be unusable without more priming and context massaging and whatever you call this, because these things just changed massively. There will be mix-ups, there will be errors. Good luck, vibe coders around the world. Actor isolated closures are sendable since Swift 6. Just mark this whole section as outdated. Right? Yes. Before Swift 6. No sendability implied. Sendable, that's not searchable. Sendable conformance. Like sendability is not a perfect match for sendable, so if I would search for sendable, then sendability will not be found. That's not good. Make it searchable, use the proper terms, and then if it's a protocol and a proper noun, you know, this works. We're not sendable by default, you needed to annotate. Still fair. also a fitting hashtag for the whole node now. Global actor isolated closures are also sendable, just like classes, since SE 0316. Let's copy the reference here again. Grab Matthews. Oops. Matthews source code example as well. Was he always using tabs in the code? I guess. Fix for subclassing is a little strange. Yeah, we captured that. Implications. Workarounds no longer necessary. Yes, I guess the closure stuff, for example. I don't know what kind of workarounds people would have deployed for the subclassing thing. Will it affect me? I classify this as mostly a bug fix style proposal. Yes. Makes sense. Getting smarter now makes more sense than before. Who would have thunk? If you start reading from the beginning, then the end makes more sense. Going through the proposals. What do you mean going through the proposals? You wrote it. Cheating, Matt. The language has made enormous strides in improving database safety. Good read on how language model adoption is going. Yeah, still a wild guess. There's no telemetry for this. But what is the, do we still, okay. We have the cool stuff we've extracted and revised. I started this empty node because I wanted to process Matthew's own blog post, but in the end, there's not much left except the links. There was this rule, global actor equals sendability. We captured that. We also captured the closure stuff, and the link isn't reflecting the new title, but that's not a problem, because maybe I will not use these anyway. The compiler treats sendable types as non-isolated within its defining module. This is still a thing. Can I please get my... No, I cannot get my clipboard manager, so I need to copy the reference. Whoops. So I need to copy the reference like a potato person manually. This is still something new that is not covered in the rest that I've processed. I admit I haven't read through either of the linked proposals, not before, not during the session right now. So, as far as I'm concerned, personally concerned, Matthew's blog post is my personal source for this kind of statement, for this information. So, even though this is a even though this is probably not the source of information, there's probably a primary source somewhere, maybe one of these proposals, Swift evolution proposals, maybe another Swift evolution proposal, maybe this is written down somewhere else in the language handbook, I don't know. But as far as I understand the language right now, this is the best that I have. This is the best source that I have. Matthew is my best source for this information. So I'm keeping it as is right now. But there's potential to look for a Swift evolution proposal, so on and so on. Let's leave it to do. For a future me. Maybe explicitly said in SE 0434. Oh, what was the other one? 0316, I guess. 0316. Primary source. I would find the primary source if I wrote a book on Swift concurrency. For my day-to-day work, this is good enough. Matthew is an amazing source of information, so I don't mind. But this note still has no title. Sendable protocol conformance tells the compiler that the conforming type is safe to use from any isolation domain. The compiler treats a sendable type is non-isolated. This is an implication of the sendable protocol. Let's try. What about sendable conformance? That's what it's about. Tells the compiler conforming type is safe to use from any isolation domain. Sendable conformance makes type. Well, that's sendability. That's a definition of sendability. You can put it into any isolation domains. You can pass isolation domain boundaries. These are still two things. Sendable conformance allows, like this is still something different. These two are not connected. You see, I have a hard time with this. Sendable types are non-isolated. What exactly did Matt say there? It looks like these things don't follow from each other. If they are sendable, the compiler treats them as non-isolated within its defining module, new information. Now is the next sentence backing this up or explaining this? The compiler knows that because they are sendable, they are actually safe to use from any domain. Okay, but if they are safe to use from any domain, does that equal not being isolated? Maybe. Being isolated means you can only use it from the isolation domain. Being non-isolated means you can use it from any domain. I'm wrapping my head around this because the non-isolated keyword I rarely use, and adding this still feels wrongly. By the way, it still feels like I'm cheating, like I'm putting in escape hatches for code that I haven't thought through. But this is not the case. Non-isolated, the keyword, has its uses, and typing it out is not a red flag. It's a It's just helping the compiler understand what's going on, what you want to express. There are legitimate usages for non-isolated functions that are not quick fixes. Non-isolated unsafe, however, that's probably harder to reason about, but non-isolated is perfectly fine. So with that framing in mind, conforming type is safe to use from any isolation domain without additional isolation. Sendable types are non-isolated. Sendable type members are by default non-isolated. Is this true? That ascendable types members, functions and so on, are by default non-isolated. Non-isolated. Being sendable across isolation domains means not being isolated to a domain. I don't know. At least within the defining module. You could say that ascendable types members are by default non-isolate, being ascendable across a domain. These are my words. Let's start with these. Open with these. Sendable protocol conformance tells the compiler conforming type is safe to use from any isolation domain. This is factual, whatever statement, technical statement that explains why and how. Like this is mechanics. The compiler treats sendable types. This is interesting detail. Like within its defined module, that's a limitation. Being sendable means at the domain. The compiler is non-isolated within its defining module. The guarantee. I need to look this up. No, I need to understand this properly to make sense of this node that is being that is spawning, that's emerging. The guarantee applies to the defining module only, though. What are the what are these? This is also lifted from paraphrase from Matt's article. Sendable type essentially marks members as non-isolated. I'm not sure if this is true or if it's an oversimplification, but it's a hypothesis. This is one kind of backup. This is, I need to research it. Okay, two backups. This is not a tip that I would like spread out because it's unproven. That's why I call it hypothesis. I don't know, but interesting nevertheless. Sendable types. But now this is an orphaned node. We started this node as a scratchpad, as a sandbox to work through Matthew's post, but we ended with this removing all the links, and now this is not the overview anymore, and also there's no link coming back to it. But maybe we can use it now that this node expresses something differently. Maybe we can use it as a backup. Just the classes are maybe here. If you annotate the type of the global actor, the type automatically and implicitly becomes sendable. Types hierarchy is required to be isolated. Why not? Let's try to option escape. Sendable essentially marks. Think of sendable marking. That doesn't fit well. What else do I have that's using the sendable hashtag? Shortcuts on camera. Broken sendable essentially marks protocol conform sufficient condition for Swift actor usage. Sendable protocol conform marks the whole type as needing to be sendable protocols. Okay. Value types of the sender conform to as easily. Reference types. When writing the actor implementation, check that necessary met. Actor. Yeah. If a protocol is sendable, conforming types, a class conforming to the protocol is sendable. That's easy for value types. They're just sendable data blobs if you want. But for reference types, you need to do something else. What is this something else? You need to turn them into actors. Why do you need to turn them into actors? Because only actors are sendable because they protect the internal state. Essentially marks type members as non-isolated. It's also about isolation. But if the type members are non-isolated, what does this make? Like, how do I combine these two information? How do I combine sendable protocol conformance is sufficient for Swift actor usage? I don't know. Conforming type to sendable. Conforming to sendable tells the compiler that the type is essentially non-isolated. Not isolated to not isolated, period. It can pass isolation domains, pass between cross isolation domains. I don't know. Sendable protocols. Reference types. That's the interesting part. Sendable reference types. Yeah, making a reference type sendable requires global actor isolation or defining a custom actor to protect the internal mutable state. because to make it sendable, it has to be not isolated or self-isolate. Is this really a thing? Like, it feels like I'm approaching the same topic from two directions, but I'm not grasping it correctly. Oh man, this takes so much time, you see? This takes much longer than processing the actual article, but these are the genuine questions that come up if I think about this, and then I wonder, what does anything even mean? Making a reference type sendable requires global actor isolation. Also, global actor isolation types are sendable by default. I should fix the auto-completion to only paste the either global actor isolation. I should fix the auto-completion to only paste the ID, not the whole thing, because cutting then is quite painful. Defining a custom actor protect the state. Sufficient conditional Swift actor usage. Oh, sounds good. That's a great reference. Like this. Or like this. That's making reference type sendable. An actor applies different kinds of rules. I don't know. I need to research this more. But not today, not right now. I need to research this more. How do... how does isolation, non-isolation, and actor isolation and sendability play together? No question mark, because question marks in macOS file names, you never know. I don't quite grasp how the following two forces in Swift concurrency, concurrency, how the two forces play together. Okay. Again, I don't know. This is very colloquial because I have no good grasp. First, conforming tells them that I'm not isolated. But also custom actors Swift actors conformed like this. What's the second for Swift actors? Isolate their members by default. with the global actor. So the global actor, starting with global actor isolation, grants sendable conforms automatically for free in most cases. Because the global actor takes care of managing access to the members' properties, but also methods. A custom actor protects its members starting with a sendable protocol makes the... Does it really make... Maybe the hypothesis is wrong. Maybe starting with a sendable protocol marks the members of the protocol as being able to cross isolation domain boundaries. That in turn means the members need not be isolated. The custom actor protects its members by isolating them. I need to try this by isolating them. A custom actor is also a tool, is also a good way. It's also useful when you have a sendable protocol. But why? Because the actor itself is sendable by virtue of its protection guarantees. Yeah, let's see. Let's wrap this up. I'll ask Matt about feedback here and send him the notes and whether my hypothesis is any good. Let's see. I hope you found the session insightful or maybe just informative. The actual processing of Matthew's blog post went rather quick. I mean, I took more time because I commented everything, read things aloud, followed a couple of links. If I did this just in my head and in my notes without a camera, then this would have been like over much more quickly. But the interesting part then comes from thinking about the consequences. The interesting part then is thinking about the consequences. And these are questions I need to ask myself and figure out to truly grasp the implications of all of this. How do these things play together? I was essentially collecting two different forces that I had a rough grasp on, and I felt like, well, this doesn't gel together. And then I wrote a couple of sentences here to explain my current understanding from the top of my head, which is basically the Feynman technique of explaining stuff to yourself in written form so you see the gaps in your understanding. And here is a gap in my understanding, and I need to fill it. I can't fill it right now. I will not fill it right now, but maybe I can fill it in the next couple of days, weeks. What does that make the protocol's members do? Maybe a Swift source file and asking the compiler would have provided a clear answer right now. I don't know. I need to experiment. Does this one tell? Swift actor usage? Nope. There's no code example. Premature actor usage. The actor status sender, because then it's not isolated. Yeah, this is tough. It's a tough nut to crack. Necessary condition to introduce an actor. You have non-sendable state, which means it has to be isolated. Needing to conform to sendable protocols from other packages. Is a sufficient condition? The reason for this existence may be wrong. Let's try to change again. So this is not like sendable protocols are not a good idea, I recall. I don't know. Weird forces playing together. I need to restructure this a bit. Anyway, thank you for watching. I hope you enjoy the rest of your day, and happy Zettelkasting and note-taking, and good luck understanding Swift 6 concurrency mode. This is going to be a tough nut to crack for us all. So, see you in the next one.